Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2021, Paper-1, Mathematics, and the question for this video is this. For any 3x3 matrix M, let M between two vertical lines denote the determinant of M, let I be the 3x3 identity matrix, let E and F be two 3x3 matrices such that I minus EF is invertible and I minus EF inverse is G. Then which of the following statements is or are true? There are four options. It is a multiple choice, multiple correct type question. Let's explore. So here, inverse of I minus EF is G. So I can say I minus EF times G is identity matrix. So is G times I minus EF. Because inverse of I minus EF is G. So that essentially means G minus EFG is equal to identity matrix is equal to G minus GEF. Now clearly you can see, comparing both sides, EFG is equal to GEF. So EFG equal to GEF, C is indeed correct. Now let's first explore B and D options. Here if we see carefully, the right hand side is the same. The prefactor on left hand side is also the same. The post factor on left hand side has difference of plus minus sign. So let's consider this left hand side and move ahead of both these options combinedly. Let's consider. So E minus FE times I plus minus FGE. So what does this become? I into I is I plus minus FGE, or rather minus FE multiplied by I we may do first. Now I multiplied by plus minus FGE is plus minus FGE, and minus times plus minus becomes minus plus, and it becomes FE FGE. So here EFG is same as GEF. So EFG is same as GEF. So I can take FGE common. It becomes I minus FE plus minus. If I take FGE common, I get I minus FGE has been taken common. So what I am left with is FE. So just to help you understand this expression, let me rewrite as FGE FE, and FGE, the prefactor I have taken common, plus minus FGE when I take common, it becomes I, and since instead of plus minus here it is minus plus, so when I take plus minus common it becomes minus, so I minus FE. Now here G is I minus EF inverse. I minus EF inverse. E I minus FE. So what does this become? If you see carefully, let me write it step by step. E multiplied by I is E, and EI you can even write as IE, doesn't matter, because EI is same as IE is same as E, minus EFE. Now here, interestingly, you can take E as common as post factor. So it becomes I minus FE plus minus F I minus EF inverse. So when you take E common as post factor, what you are left with is I minus EF E. So that essentially becomes, this becomes identity matrix, because inverse being multiplied by the matrix gives identity matrix, and you are left with, and yes, identity matrix multiplied by any matrix is the matrix itself, so you are left with plus minus FE. So clearly when you take plus, so we started with plus minus, so when you take plus, then you are getting identity matrix. When you are taking minus, we are essentially getting I minus 2FE and not necessarily identity matrix. So that essentially means B is correct. When we take plus, we get identity matrix. However, with minus, it's not so. So B is correct. D is incorrect. Now, having got B correct, based on this, we can explore option A. So when you multiply I into I is I minus FE plus FGE minus FE FGE equal to identity matrix. So that essentially means FE, identity matrix, you may so-called cancel out. Minus FE you take on other side, you get FE equal to FGE minus FE FGE. Now this FGE you may take, since I want I minus FE, so you may take FGE post factor common. So you may say FE is equal to I minus FE, since we are taking post factor common, FGE. Now since these two are equal, if you take determinant on both sides, you get determinant of FE, which is supposed to be determinant of F multiplied by determinant of E, because E and F are same order square matrices, is equal to determinant of I minus FE multiplied by determinant of FGE, which is essentially same as option A. So option A is also correct. So in this question, the answer is A, B, C. Thanks for listening. Stay tuned for the next question.